Dear students, today we will discuss very important topic known as pipelining. You know that electric pulses travel through wire no faster than the speed of light, and you know that speed light travels 1 foot in a nanosecond, so 1 billionth of second. So in 1 second it can reach billionth of foot from one place to another place. And CPU requires at least 2 nanoseconds to fetch the instruction from the main memory. So for example, if a CPU want to fetch the instruction, it will give a signal to the main memory that I want this instruction, and then that instruction will be given back to the CPU. So such 2 steps will involve 2 nanoseconds. So this is just fetching, and then the instruction will be decoded and then it will be executed. So in fact, it would need several nanoseconds to perform this task. So increasing execution speed is not the only way to increase the CPU throughput. So first of all, we should define what is the throughput. Throughput is basically the amount of work done by a machine in a specified time. So for example, if you want to increase the speed of the computer, one way would be to travel faster than the speed of light, which is not possible at the moment. So the next thing is that making the procedure in such a way that it can help us to actually expand the speed and throughput of the overall system. So let's see how we do it using pipelining. So increasing throughput without increasing the speed is achieved through pipelining. Allow steps in machine cycle to overlap. So here is an example for you. So these are the times, for example, from time T1 to T15, and I want to execute 5 instructions. So without time pipelining, what would be the procedure? At time T1, first instruction will be fetched. At time T2, first instruction will be decoded. At time T3, first instruction will be executed. So this means we would need 3 time slots, maybe these are nanoseconds, to actually complete the first instruction to be executed. And once the instruction has been executed, at time T4, the second instruction will be fetched and then decoded and executed until time T6. Then at T7, instruction number 3 will be fetched and finished by T9. And at T10, we will be fetching instruction number 4, and it will be completing its cycle until time T12. And at time T13, we will fetch 5th number instruction, and it will be executed by the time T15. However, using pipelining, it says that at time T1, let's fetch instruction number 1. But at time T2, let's do 2 things. 1, we should decode the instruction number 1, and second, we should fetch the next instruction, the instruction number 2. And at time T3, we should execute the instruction number 1, we should decode the instruction number 2, and we should fetch the instruction number 3. So in such a scenario, we are going to finish all of the execution of 5 instructions in only T7 time slots. So which means if this time is in nanoseconds, so this means here we have required 7 nanoseconds, and here we need 15 nanoseconds for just 5 instructions. And you know, in computer science, we have billion of instructions, and our CPU can perform billion of instructions in 1 second. So if such a pipelining is used, so you can see that how much there is an efficiency that can be achieved without increasing the speed of data transfer. So which was the claim on the previous slide. And then the modern machines not only do the things which we have shown in the previous slide. That was a very basic example. They are even doing many more things. For example, they are fetching instructions parallelly, and they are executing even the instruction which are not relying on each other at the same time using parallel processing. So if we conclude the pipelining, so we need to increase the throughput of the computer. So overall work done by a computer within a specified time. And we have seen in the previous example that it has finished in 7 nanoseconds the same task which was done without pipelining in 15 nanoseconds. So we have discussed the pipelining concept. We have performed an example to see what it is doing, and then we have discussed that modern computers have even more capabilities to increase the speed or the throughput of computer without increasing the data transfer rate.